Hey guys, Brandon here, and as I said at the end of the last podcast, that I'd be discussing an article that I recently read about the expanding universe. Now, what this article entails is it's from the New York Times, and it's about something called the Planck satellite, which uses if I can speak uses microwaves. As we mentioned before, that's a slightly longer wavelength and slightly lower energy than the infrared that we see. The same thing you use to heat up your food, all your leftovers. The exact same thing. They use microwaves to actually map out the entire universe. And they first discovered this technique back in the 1960s. Two young gentlemen were trying to actually figure out any background radiation that would be interfering with a local radio station. And in doing so, they discovered what's called the cosmic microwave background radiation. It's essentially, think of it as the same as the residual heat left over when a bomb goes off, only this CMB for short is the residual energy left over from the Big Bang, which kind of started literally everything. It was the beginning of the universe, as the theory goes. With the microwaves, they're able to, as I said, map out the entire known universe. And with this podcast, I'm just going to kind of give you some quick numbers, just some updates that they've had to make. Um, Previous theory dictated that the universe was 13.7 billion years old. But with this new discovery, or with this new imaging that they have, they actually see that it's 13.8 billion years old. Not a drastic difference if you just think of it as 13.7 versus 13.8, but you add that billions of years, and that's actually a 100 million year difference. So obviously that's a pretty cool little thing that they're looking at. It kind of changes the numbers in the theory a little. Another thing is that they used to think that the universe was comprised of 4% regular matter, so that's us, everything. It's what stars are made of, gas clouds, anything that interacts with light. And then dark matter, which was also discovered in the 1960s by Vera Rubin, I believe her name was. It's any matter that doesn't interact with light. And there's two big theories on that, whether you go with the WIMPs, weakly interacting microscopic particles. No. Yes, that is correct. Which is quantum-sized particles that literally have no interaction with light. So all the things that we see right now, neutrinos, protons, neutrons, electrons, muons, all those interact with light, and now they're looking at particles that don't interact with light. And then there's also MACHOs, massive cold halo objects, essentially dead solar systems, stars that have burned out that are no longer emitting light, and we can no longer see those systems unless they pass in front of something, which even then is nearly impossible to detect. And they also previously had it that 71% of the universe was comprised of this mysterious dark energy, which is kind of the driving force behind the universe's expansion. The best way to think of it is as the repelling force to gravity. Gravity pulls matter together, dark energy pushes it apart. And that 4%, 25%, and 71% is now upgraded to 4.9% regular matter, 27% dark matter, and only 68% dark energy. So again, this is really changing the models, changing everything that we know about, the composition of the universe. And again, these numbers may not seem like a lot, but when you think about it in the grand scheme of things, even the tiniest little measurement can completely change any theory known to man. And just the last kind of number they throw out is the rate of expansion. Previously, it was considered to be 69 kilometers per second, per megaparsec, with megaparsec just being a massive measurement of distance that is used in astrophysics, astronomy, and cosmology, because obviously we can't measure in kilometers to everything, because otherwise we would run out of paper. Previously, it was at 69 kilometers per second per megaparsec, but now it's considered to be 67. So a lot of the theories about where the universe is going, initial conditions at the beginning of the universe, all those are beginning to get their little fine tweaks and small adjustments. So we really are honing in on that kind of theory of everything. And with the recent discovery of the Higgs boson, which you can read more about online, obviously, or um, great day to showcase books. I have a book called Higgs by Jim Baggett. I haven't actually had a chance to read this yet. I'm still hammering through a few other books, mostly Lord of the Rings stuff, but it definitely seemed like an interesting read, and that's why I picked it up. But obviously, with everything kind of coming out at once, we're finally zeroing in on that big link between relativity, which is the study of all the big stuff, as made famous by Einstein, versus the theories of quantum mechanics, which is kind of kickstarted by a lot of great people, especially in the early 20th century. That's just kind of something that you kind of see finally the day-to-day events of scientists, some of the big things that they're looking at, and what all these things that you learn in class are really kind of coming to fruition in, why it all matters, and just basically why we study what we study. I hope you guys enjoy, and have a great day.